Hi, we're back here with statistics. Today's video we will be discussing more of probability, which is located in your textbook in Chapter 6. We are going to focus on two concepts, the binomial probability distribution and the Poisson probability distribution. Now, I am going to go over to the .chem. And this is the handout you should have printed out. I'm going to zoom in here a little bit. You'll see it says Chapter 6, Discrete Probability. I'm going to let you, outside of this video, fill out the definitions of discrete, continuous, mean, and variance. What I want to concentrate on during this video is the binomial distribution, and there's the formula. If you notice, it's made up of the combination key. Again, pi in this class means percent raised to the x power. Again, this is percent n minus x. So what are they? C denotes the combination key. N is the number of trials, and I think when we do more examples, you'll understand that. X is the random variable. I tell students, remember, X is in the question. That's how you remember it. In the question. You should write that in bold in your notes. Okay? So the first question I'm going to ask you is, if you go to my PowerPoints, is there are 5 flights and the probability of any flight being late is 20%. I want to know the probability of exactly one flight being late. Okay, so what defines it as a binomial? There are 2 outcomes. It's either late or not late. The other characteristic of a binomial distribution is there's a fixed number of trials. There are only 5 planes that are coming in. So only 5, 4, 3, 2, 0 planes can be late. You can't have 10 flights late. You can't have 1,000,000. We are talking about a fixed number of flights coming in from Bedford, Michigan into Albany Airport, for example. So N is the number of trials, 5. Pi, or the percent, was 20% have a possibility of being late. And in this question, I said exactly 1. So X is 1. I said you get X from the question. So over here, I substituted in to here's my binomial formula. We determined we should use it. 5 combination key 1 times 0.20 raised to the 1 power times 1 minus 0.2, 5 minus 1. Okay? After each of this, 5 combination 1, hit enter, then hit times. Make sure you put parentheses around the exponent. When you do this calculation, you should get 0.4096. That means there's a 0.4096 chance that exactly 1 flight is late. Here, and I think this is the first one, what's the probability of 0 flights late? Well, here, N is still 5, percent is still 0.2, but X turns to 0. Again, I substituted it into the equation, and this time I got 0.3277. Okay? Now, I want to talk to you a little bit, and this is going at a fast pace. You should continue with a bunch of binomial problems, but in a few slides, you will see cumulative binomial. Cumulative binomial just means something like, I want to know the probability of less than 2 of those flights. Well, if I have the probability of 0, which is 0.3277, I have the probability of exactly 1 flight being late, 0.4096. there are, 2, 3, 4, 5 flights. I'm not even going to calculate the rest. But if I ask you, what's the probability of less than 2 flights late? Less than 2, I draw a horizontal line, and less than 2 is up. I want to know the probability of 0 or 1 flights. I add them. Right here I show you, I add those 2 flights. And if I add those 2 flights, I get 7, 3. I believe a probability of 0.7373. Okay? This is called the cumulative binomial distribution. I could say to you, what's the probability of any flight being late? If I did that, let's use a different color. Any flight being late, I'm looking for this area. I'm looking for this probability. Well, I know all the probabilities have to add up to be 1. This is what I'm looking for. I could calculate 1, 2, 3, 4, 5, but there's an easier way with the complement rule. I can take 1 minus 0 and get this probability. So I could say 1 minus 0.3277, and I can get this probability. Let's review that for a second. I want to know the probability of any flights late. That means all of these, 1, 2, 3, 4, 5. Instead of doing 5 calculations, I know all of these probabilities equal 1. I've already calculated the probability of 0. So if I subtract 1 minus that probability, I will get the probability of 1, 2, 3, 4, 5. And I show you that on the PowerPoint presentation. Okay, so that is the binomial distribution and the cumulative binomial distribution. I'd like to talk a little bit about the Poisson. The Poisson is very similar to the binomial, except 2 characteristics make it different. First of all, you have to know what mu is. Mu is a rate. And now in your PowerPoints, I could say the number of mistakes per page on a newspaper, the number of defects in 10 square yards of carpeting, the number of goals per soccer game. You'll notice all of those, I say the word per, those are rates, okay? So you need to know the rate. I might give you the rate, or you might calculate the rate. And in my PowerPoint presentation, I expand on how to calculate it. But let's look at this. Example number 8 on your handout. Suppose a random sample of 1,000 flights. Oh, let me back up. There is your formula. Mu is rate. X is still from the question. And you'll notice E here. E. That is located above your natural log key, and it's a constant. E is 2.71A28. If you have trouble finding it on your key, on your formula sheet, I give you that constant, but you should be able to find it. Okay, so we've defined all the variables. So let's look at our first example. Suppose a random sample of 1,000 flights show a total of 300 bags were lost. Thus, the arithmetic mean number of lost bags is 0.3. How did I calculate that? 300 divided by 1,000, there's 0.3 lost bags per flight. That's my rate. So therefore, mu equals 0.3. Okay? If the number of bags lost per flight follows a Poisson distribution with mu equals 0.3, find the probability of not losing any bags. So x equals 0. So this is a Poisson. Now, technically, there could be an infinite number of bags lost. There is no fixed number of trials in this example. That defines it as a Poisson. Okay, we substituted in 0.3 raised to the 0, e raised to the negative 0.3, divided by 0 factorial. Now, when you put this in the calculator, that's the most difficult. 0.3 raised to the 0 power, enter. Then hit the multiplication sign and second natural log to get e. Where you'll make a mistake, don't forget to change the sign. Hit your change sign button on your calculator, and it should be mu here, not x. Mu, 0.3, close parentheses, enter, divided by 0 factorial. Remember, 0 factorial is under your probability button on your calculator. When you do this calculation, you should get 0.7408. Okay? Now that you've done both of those, a binomial and a Poisson, I have a little good news for you. We have binomial and Poisson tables that sometimes we can use them. Sometimes. So, let's see. For example, let's go back to the flight. There were this, by the way, this table is located in the back of your book. So pull it out. B9. In your example of the binomial distribution of flights, we had a sample size of 5. Here's a sample size of 5. And we had a percent of 0.2. So therefore, with a number of trials of 5, a percent of 0.2, exactly 0 flights being late is right there on your table, 0.328. Exactly 1 flight, 0.410. Exactly 2 flights being late, 0.205. 3 flights, 0.051. 4 flights, 0.006. And 0% chance, or 0.00, or no flight chance of 5 flights being late. Okay? You can pull those percents right off of your table rather than using the binomial formula. Okay? Why didn't I tell you this originally? Well, if you had a percent or a percent of 0.12, it's not in there. So therefore, I had to teach you that. And on the test, I will give you one from the table, but I will give you one that you will have to calculate through the binomial distribution. There's also the Poisson table. The Poisson table, you need to know mu. And it's, so for example, we had a mu of 0.3, and here are our probabilities. Okay? So all you have to know for mu is mu and the x. Okay? Thank you very much. I'm going to go back to the instructor here. Thank you very much for your time on Chapter 6. If you have any questions, I want to emphasize, come and see me during my office hour. Email me. Redo the problems on the PowerPoint presentations over and over again. Do the required problems if I give them to you in my hybrid class. And don't forget the additional problems that are on the handout. Thank you very much.